All right. Hello, everybody. My name is James Desjardins from elementarymusicteacher.com, and here with me today is Dr. Peter Pfordresher,
Hmm.
a psychology professor at the University at Buffalo, the director of the Auditory Perception and Action Lab at
Hmm.
UB, and one of 7 researchers that is currently working on the Seattle Singing Accuracy Protocol, something that may have some serious implications and uses in elementary music. And a lot of different music teachers could use it. So thank you for being with us, Dr. Pfordresher. Can we begin by talking about that Seattle Singing Accuracy Protocol and how you got involved in the project?
Okay, so for quite some time I've been interested in singing accuracy from a psychology standpoint. So I come from a cognitive psychology background. And so for a long time I've been interested in the basic question of how is it that people are able to match pitches with their voice, what kind of basic processes involved in terms of converting auditory perception into muscle movements of these elusive sort that we have to engage in when we're singing. But I've also always been interested in the more applied questions surrounding the problems many people have in education, but then also outside the context of education too, in terms of their abilities to sing, people's self-image about themselves as a singer, and the positive, negative consequences of people feeling that they're unable to sing, and the frustration that I think educators and people alike feel, and how hard it can be to take someone who has trouble singing and help them out. All right, so what the SAP is involved, we can shorten it to that acronym, is at a first step, right? The first step is basically diagnosing what kind of levels of proficiency might be exhibited by people at all sorts of age groups across a broad population. One of the exciting things now in research is with the internet, you're able to collect data from incredibly large samples, which for a long time in psychology we couldn't do. We just had to rely on these smallish intro to psychology samples, or going in the schools and things like that as much as we could. But this ability to gather huge amounts of data is relatively new. People in production haven't really been able to do that recently, so the SAP is part in an effort to do that kind of thing. The next stages we're hoping for, and these are things that are still very much in development, is trying to work towards some possible interventions. The SAP doesn't do that. The SAP is just at kind of diagnosing where people are and trying to do it in a way that's accessible. That means you don't have to go into a lab. That can be done in school settings with the proper kind of ethical oversight, but that could also be done by people of age, you know, logging onto the internet, who might be just interested in their singing abilities, might want to learn more about it, and that also helps us too.
All right. So tell us a little bit about how someone takes the test or administers the protocol to,
Hmm.
say, students, or if you could take it yourself.
Okay. Yes. Yeah. So let me tell you a little bit more about that. And I realized actually in answer your last question, in a way I didn't answer your last question, because I didn't talk about my important collaboration with Stephen Demarest, who I've mentioned to you before. And so
Yeah.
Steve Demarest is a music educator who's done a lot of different things, but one of his interests is in singing accuracy. And some years ago, he kind of cornered me at a conference and said, well, you know, you're interested in this, I'm interested in this, let's team up. So couple things that emerged out of that collaboration. One is the symposium that the SAP is named after. So last year, 7 of us, you mentioned the 7 before, the Magnificent 7, got together in this great symposium that he arranged at Seattle. He was at that point a professor at the University of Washington in Seattle. He's now at Northwestern, but we all met in Seattle, so we decided to name it after that. And we all kind of agreed on a set of tasks that we'd like people to do. And another related offshoot of that is that he and I submitted a grant proposal to the National Association for Music Education to develop an online measure. And this online measure is what we're talking about today. So there's sort of the conceptual angle comes out of this symposium, but then the actual ability to put a product together came out of this grant proposal that Steve Demarest is the principal investigator on. And so we've taken the ideas that come from the symposium, and those are about to be published in a special issue of the journal Music Perception. So early in 2015, a special issue of this journal should come out, all about singing accuracy and all about the symposium. And one of those articles is going to be a description of this protocol. Now, the protocol could be variations on a theme, and the online measure is a variation on the theme. So here's what the online measure is targeted to be. I should mention it is still in development, but we've gotten quite far, right? So we have a workable version. It's not live yet, but we're hoping in the early part of the next year to be live. So someone will access it via a URL. I don't think we're far enough along with the URL for me to tell you what it's going to be yet, but I certainly can get in touch with you later so that you can distribute it to your folks there.
That would be great. Yeah, that sounds great.
And the first thing that will happen is there'll be some way in which people consent to the procedure. I mean, even though this is an incredibly innocuous thing, we'll probably have some sort of thing that you click through to say that I understand I am 18, because the age of majority is important here. So for people like yourself who might be, actually I'm not sure what age group you're teaching, but if you're teaching younger, probably teaching younger than 18-year-olds.
I'm K through 5, so
yeah,
yes.
K through 5. Yeah, so you'll have a slightly different use than we will. There'll be some different procedures where you get parental consent, child assent, or whatever it is that needs to happen. And then people will answer some demographic questions about their own musical background, and depending on how much musical background, you might have to answer more questions or fewer questions. And all this will be done with a kind of nice user interface where you see boxes, with words on them and so on like that. So for children kind of K through 3, you'd probably have an instructor sitting next to them, guiding them through that. Assuming that they might not be quite at that reading level to be comfortable with this. Then the first tasks we have people do are basically kind of warm-up tasks. So right now we have a task where we're asking people to count backwards from 10. That could be modified if you have a young kid who maybe isn't ready to count backwards from 10 yet, let's say kindergarten or something like that. And that's just basically to get people using their voice and get some measures of their pitch. Then we ask people to sing a familiar song from memory. Right now, we have a kind of menu they can choose from, so it can be Happy Birthday, it can be Twinkle Twinkle, it can be Farajaka, it could be Mary Had a Little Lamb, and I think we might be adding Jingle Bells to that too. All of which seem to be pretty popular songs. Happy Birthday dominates the literature at this point, which is in a way kind of funny because it's actually a pretty hard song, but a lot of people know it.
That's true compared to the rest of them that you mentioned.
Yes, exactly. Yes. And then the final task is to ask people to try and hold a note that's comfortable for them to sing, just to kind of get a measure of what's comfortable for them. Then some little bit of computer magic happens. We have an algorithm we're working with that was developed in IRCAM, a place in France, called YIN, which extracts the fundamental frequency of wave files that we record. So as people are producing these tasks, we're getting digital audio wave files from them, and then this program extracts the fundamental frequencies from that, and then we've developed a program that kind of pools together all of these tasks and gets an idea of the range and gets an idea of the middle of someone's range. And from that we select a kind of key which is good for someone. Now this ends up being important. As you might know from the music education literature, there's a lot of sensitivity in kids to what key you have them sing in. There's also a lot of sensitivity to the kind of voice that they're imitating too. So if you have a kid trying to imitate a piano, right, sing a song back based on a piano that's an octave lower than they're supposed to be, they'll fall apart. But if you have them imitate a female voice that's in their key, that's comfortable for them, they'll often do much better. So we want to make this task as easy as possible for the individual to do well at.
I see. All right. So let's review.
Mm-hmm.
In order to start taking the test, you speak something, right? Mm-hmm. Count backwards from 10, right? That's with your talking voice, right?
Yeah. Talking voice. Mm-hmm.
And you sing Happy Birthday, right? And you sing one note, right?
Exactly.
And then the computer decides what key you need to sing in for the test.
It comes up with an estimate that's the key that's best for you from a set of keys. Yeah.
Okay. All right. Okay.
And then it has you go through a bunch of kind of call and response tasks. And we're going to put in some examples and some practice to get people to do that. And in each of these call and response tasks, you hear some sort of tune or just a note that you need to listen to and try and sing back. And while you're listening, you'll see some kind of icon, like someone doing this, or a speaker we haven't chosen yet, but something communicating to you that you're not supposed to sing yet. So you might hear someone go da 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 da, and then a little microphone icon comes up, green light saying go, and then you take a shot at it. You go, da, 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 da. Yeah, potentially, or something very different from that. And then you do this a bunch of times, and some of the tasks will be just a single note, maybe a single note repeated a few times, like ba 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 ba. Sometimes it'll be just one pitch change, like da 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 da, like that. Twinkle. And sometimes it'll be a short tune with just 4 notes. And we won't go beyond 4 notes because then it gets tricky. Sometimes people will forget a note, and then you have to deal with those sorts of things. And each time someone does this, listen, sing back, we again run this computer algorithm, which takes the audio file that someone's produced, which is kind of a temporary file, looks at the fundamental frequencies of their voice, figures out where the boundaries of their notes are, which is something of a to-do. It's harder to get a computer to do that than you might think, but we've got a program that is pretty good at that. And then it compares what you sung to what you're trying to sing and looks at how different those are. And comes up with an accuracy score each time. And then by the time you finish all these tasks, you get a kind of summary score. So this is how many notes you sang, which would be considered wrong notes. This is how far off you were, and let's say the number of cents or musical semitones. And then we're probably going to also break it down by the kind of task you're doing. So when you had to sing 4 different pitches, this is how well you did. When you just had to sing a single pitch, this is how well you did. When you just sang a tune which is 1 pitch change, this is how well you did. And people can do with that what they wish. From a research perspective, these different tasks end up being actually pretty important. So we're finding so far that the main task where we see improvement across the age groups is actually just the ability to match a single pitch. Kindergartners do a lot better at singing melodies than they do at matching single pitches. And so, whereas it kind of reverses for college students. And so there's this kind of, increase in the ability to think maybe analytically about pitches and imitate them outside of their context.
Exactly, right, because it's the combination of pitches, you're getting some kind of tonal context.
Exactly.
Now, when you put the tasks in order, do they go in order of difficulty in a sequence like that?
We've gone back and forth on that. I think we're probably just going to mix them all up because if you put them in a particular kind of order, you have to contend with practice effects. And practice effects are always there, or the flip side of practice effects, which is fatigue effects. And because this is going to be something that we're just throwing out to the masses, and we're not going to be able to set up kind of a controlled experimental context where we have things, we're probably just going to mix them all up in a random order, give people a lot of trials, and when you do that, you hope that any kind of carryover effects from one kind of tune to another kind of tune averages out and washes out in the mix. So that's what we're thinking about doing. It's all in development, so if you've ideas, I'm open to them. So I mean, we don't have that much longer that we're thinking about, but we are still open to.
All right. Well, that leads us to an interesting question. What's the timeline look like for when this might be available for classroom use or for people to use?
Yeah. So we do have a target date because we have an end date for this grant, which is the end of January. Also, the programmer we've hired can't work past the end of January. So the end of January is when we're hoping.
A good target to have.
Yeah, that is our target to have. And so far, right now, it looks like we should be able to make it. It's hard to know what will happen. So what we're going to be doing in the near future is running some kind of just stress tests of it, before sending it out to the general public, sending it around to people who want to try it out and see if they can break it. All right. So if you or any people you know want to be the sort of person to try and see if you can break it, we're certainly open to that.
Well, I will certainly try to break it if that's what
Yeah.
you're looking for.
Yeah. Yeah.
I'm game.
And if no one can break it, that's all for the better. But usually the starting assumption is once you develop something on your system, it probably won't work on another system so well. So you might as well try as many different systems to see if you can work out all the little kinks that you can't imagine right at the back. I don't want to sort of drag on too much about the different tasks, but there is one more task that I should mention too in there. We do have a simple pitch discrimination task to look at perception issues. So this is a task where people listen to, it's an adaptive test where all people do is they listen to just two sine tones, one after the other, and your response is basically which one's higher than the other. So you might ask them something like, is the second note higher or lower than the first note? And if you get that one right, the next time around it gets a little harder, the difference gets a little smaller, and then things keep getting smaller until you get something wrong, and then it gets a little bigger, and then maybe it gets a little smaller, and after a while it zeroes down on a threshold for what's the smallest pitch change you can perceive. We put that in there because one of the issues out there about inaccurate singing is how much of inaccurate singing is a perceptual issue versus more of a motor control or a sensory motor connection kind of issue.
That's interesting.
That's the other big task.
Yeah, I think that will be extremely interesting to see from a teacher's perspective where things are going awry if there's a student who can't match pitch, sing, and tune.
Yes.
That kind of thing. Interesting. That's interesting. Perception versus their ability to actually produce the sound.
Exactly. Yeah. Yeah. And there's some surprising findings out there. So one of the people who was behind the protocol, a young researcher named Psyche Louis, has found a group of people who are able to sing a pitch change in the right direction. Not well, but at least go in the right direction. So if it goes up, they sing up. So they hear bum bum, and they sing bum bum. Right? So they're going up. But then if they have to label the pitch change, they are basically guessing. And they can't
they can't tell if it's going up or down.
They can't tell you consciously if it's going up or down, but they can sing it if it's going up or down. So what we think of as perception doesn't always go along with our ability to reproduce things with our motor system.
So interesting.
Yeah.
And I know that a lot of this music teachers kind of anecdotally have seen in their classrooms. I know I see a lot of kids that if they can't match a melody, then they certainly can most often could get around about the contour of the melody.
Yes, yes.
Very people can't get anything close to the kind of pum pum pum, go up, but not match those pitches. So that's interesting that this test gets really specific about seeing where that's going wrong, and possibly, as you said, if there are some implications that we can use this test to intervene and improve people's ability to match pitch, right? That's the next step, right? You said with the research that
that's the big hope. But our first approach is going to be understanding what kind of issues are out there, what kind of problems people face. And this is used as kind of an initial step, and then we can follow this up with more kind of controlled experiments that we do with various developmental stages and so on.
So interesting. All right. Well, thank you so much for taking some time with us today. I am interested to hear about all of the updates as your work progresses, and I am interested in trying it out, as I mentioned before.
Okay. Well, when we have something to send out, a kind of beta version, you will be on our list.
Awesome.
All right. Great.
That's so much fun. Okay. Well, thank you again for your time today, Dr. Pfordresher. It has been a great day.
Yes. Great for me too. Thank you so much.
Thank you. See you later.
Bye-bye.